Welcome back to CTN. I'm your host, Robert Van Sluten. In this episode, we're going to start exploring Objective-C. To begin with, two basic concepts of object-oriented programming we're going to put on the table right away. The first is objects have behavior and state. They have information in them and they have external behavior. An object's state is only accessed via its behavior. In other words, functionality is the only access you have to an object. You do not expose internal data to the outside world because you may want to re-engineer it, or it may be calculated as a result of a request for it. Objective-C. An object's behavior is defined by its methods. In other words, its functionality is a set of methods. That's the terminology. Methods are invoked by sending a message to an object. In other words, you cause things to happen by message sending. Classes can also have methods. Effectively, they are also objects, but there's only one instance of a class. You can't have multiple instances of a class. All objects in Objective-C reside on the heap and are accessed via pointers. They're not declared on the stack as they can be in, let's say, a language like C++. Memory is managed by automatic reference counting, ARC. And we'll talk about that later. Instance variables are referred to as properties. There's a mechanism for creating instance variables that give you some functionality. And towards the end of this episode, we'll be going into that in more detail. Sending messages. Well, we have this square bracket notation. You have a pointer to an object, and you send a message to it. So it's pointer, invoke the method. You're sending a message. So you're calling an instance method. You can nest these things. If the first call returns a pointer to an object, then in turn you can call an instance method on that returned value. Now, as I mentioned, classes are also objects, and the syntax is the same. You can have a class name, and you're calling a class method. You're sending a message. It's a class method that you're sending. If a class method returns a pointer to an object, you can invoke an instance method on it, sending that message. Of course, methods may have arguments. And the syntax, this is a case where you have an object. This particular method only has one argument. And my object, set value, colon, 5. You're setting the value to 5. In this case, there's two arguments. Happens to be a rectangle. Rectangle set width 3, length 2. You notice these start to read like English. You can, if you do your naming correctly, you can start to build sentence-like statements. That's invocation. How does definition work? Well, in defining a method, you start with a plus or a minus sign. Minus indicates it's an instance method. Plus indicates that it's a class method. Methods have return types. In this case, it's void. You have a name, in this case, set value, and it takes an argument, which is of type int, basic type, and an argument name, the name of the variable. Now, this pattern can repeat. In other words, if you had a second argument, you'd have the argument colon, the type, and the value. Of course, if you don't have any arguments at all, if it's a method which takes no arguments, you would just have a name not followed by a colon. There's two special, basically, object pointers. There's self, which is yourself. You're inside a particular method for that object. And if you want to call a method on yourself, you just say self space method. Self is a pointer to your object. Super is a pointer to the super classes method, the thing that you're inheriting from, the inheritance chain. Before we move on, I want to talk about something known as reference cycles. Now, I had mentioned that we use automatic reference counting in Obj-C. What reference counting actually is it counts the number of cases where the object is pointed to. Now, we have a situation here where we have an object A points to object B, and object C points back to object B. There's a double linkage, which is pretty common. Somebody's using object A, and let's say there's this situation where it's no longer needed and it's deleted. Whatever has it goes away. A disappears. However, B and C remain in memory because the reference count for B went down to 1. Because C is still referencing it. So in this situation, we have a memory leak. And the way that's resolved is by having the concept of a reference referred to as a weak reference. In other words, a weak reference is a pointer to an object that does not increase its reference count. So even though object B is being referenced by two different objects, its reference count is only 1. So if object A gets deleted, object B will get deleted and C will also get deleted. Instance variables is a typical term for data that's inside an object, defined in the object's class. In Obj-C, there's the concept of properties. And this is what you use to define instance variables. And this is an example. There's the Obj-C language directive at property. And there's some parameterization here. In this case, it's a strong relationship. It's not weak. In other words, in a strong relationship, the reference count will go up by 1, or be 1 in this particular case. The data is non-atomic, meaning that there is no protection of it for multiple threading, which is the normal case. And in this particular instance, it's something called NS-string, which is a basic string. It's a pointer because objects are always pointed to. They're all accessed for pointers. And it's called name. Now, what this ends up doing is the property directive ends up creating the storage, ends up creating the variable, and it provides some setters and getters. So you have functionality to access the string. It generates a method called setName. So if we said self setName, and this @ Robert is a simple, quick way of creating a string object. It's shortened syntax. So we're setting the name property to Robert. Now, if I create another pointer to an NS string, I can set 8 equal to the value stored in the self object by sending the message self name, which will then return that property. Now, there's a simpler way of getting at these called dot notation. What dot notation is a shorthand. In this particular case, self.name will actually execute the set method, but it just gives you a shorter way of doing it. So self.name equals @Robert is the equivalent of what we saw before. And if I want to actually copy it or actually point to it by a different pointer, old name, I'd say it's equal to self.name that actually returns the value or a pointer to the value that is contained within the current object. One more thing, very common, is creation of objects. Typically, if you have an object pointer and you want to actually create one very common pattern is by calling alloc on the class name. What it returns is an uninitialized pointer, an uninitialized object, a pointer to it, and then you do some type of initialization. Now, many initializers have parameters. Sometimes there isn't, and you could just call a simple init. I know at this point this all seems pretty obscure, and we are very much in the introductory phases. In the next episode, we're going to jump back into Xcode, talk about Xcode sum, and then relook at the slider application and break it down into more detail. Thanks for watching.